All right, so let's do number 9. Number 9 wants us to uh, find equations of tangent lines at particular points for certain functions. So the first one is f of x is equal to the square root of x minus x at x equal to 1/4. So we will use the slope-intercept form of a line, which is y minus y1 is equal to m times x minus x1. We are given x1, which is 1/4. We need to figure out y1 and m. Well, to get y1, we plug that into f of x. So that's f of 1/4, which is the square root of 1/4 minus 1/4. And the square root of 1/4 is 1/2 minus 1/4 leaves me with 1/4. Great. To get the slope, I need to evaluate the derivative at 1/4. So I'm going to take the derivative of f. So first, let's recall that a good way of taking the derivative of a root is to rewrite it as a power. So let me just do that off to the side. The square root of x is equal to x to the 1/2. So I can apply the power rule here, and I get 1/2 times x to the minus 1/2 minus 1. And let me just rewrite this as a root. X to the minus 1/2, I can put that into the denominator and get x to the 1/2, because the negative exponent literally means that. But x to the 1/2 means the square root of x. So I'll just rewrite that as 1/2 root x minus 1. Now, to get the slope, I plug in 1/4 into the derivative. So I get 1/2 times the square root of 1/4 minus 1, which is equal to 1/2 times the square root of 1/4 is 1/2 minus 1. 1/2 times 1/2, 2 times 1/2 is 1. 1/1 minus 1 is equal to 0. So this means that I have y minus y1, which is 1/4, is equal to 0 times x minus x1, which is also 1/4. But that just goes away. We're just left with y minus 1/4 is equal to 0, which, if you really want to put this into slope-intercept form, is just y equal to 1/4. Horizontal tangent. Okay. And let's go on to the next one. The next one is g of x equal to sine of x e to the x plus cosine of x e to the x at x equal to 0. Again, we need to figure out what y1 is, because our x1, well, I'll just call this at x1 equal to 0. Our y1 is equal to g of x1, which is g of 0, which is sine of 0 times e to the 0 plus cosine of 0 times e to the 0, and sine of 0 is 0, e to the 0 is 1, cosine of 0 is 1, e to the 0 is 1. I get 0 times 1 plus 1 times 1, which is equal to 1. Fantastic. Now let's figure out the slope. To do that, I need to differentiate g. I get, by the product rule, we already did this at some point, I think, sine of x times e to the x. The product rule gives me cosine of x times e to the x, derivative of sine times e to the x, plus sine times the derivative of e to the x, which is itself. Great. Then I add the derivative of cosine, which is negative sine, so I'll just write minus sine of x times e to the x, plus cosine times the derivative of e to the x, so plus cosine of x times e to the x. You know, you don't have to simplify things, but this really simplifies down pretty simple. Sine of x e to the x minus sine of x e to the x cancels, and I'm just left with 2 cosine of x e to the x's. So that's probably the easiest way to write this out. So g prime, the slope, m, is equal to the derivative evaluated at x1, which is g prime of 0. That's 2 times cosine of 0 times e to the 0, which is 2 times 1, which is 2. And so that means that our equation is y minus y1, which is 0, is equal to 2 times x minus x1, which is 0. And 2 is the slope, of course. If you really want to put this into slope-intercept form, this gives you y is equal to 2x plus 1. Fantastic.